Okay. So, good afternoon to everyone. I will present today some observations of the RAMMER network during the summer of 2011-2012, which was the same summer where the Chuva GLM was held in Vale do Paraíba region. And this is essentially the same presentation I gave on ILDC last year. And I choose to show this work today for two reasons. First, to introduce to those who doesn't know about the RAMMER project. And second, because we didn't have any request for data on this last year for the high-speed video data. And it would be nice to show you some of the capabilities of the studies with high-speed cameras and show also what we are doing with this video. So you might want to do some similar jobs or have some ideas from what we are doing. So first of all, we have this project, the RAMMER networks, a network with 3 high-speed cameras, and now we have 4 for this last summer. And they are installed in São José dos Campos, which was close to where the X-band radar was installed last year. During that campaign, it was the first campaign of the RAMMER's network. So we had only 2 operational sensors during that time, and one was installed into the same site of the Chuva radar, and the other was installed in an antenna in a TV station. So we had 3 main objectives of this project. One of them was observe the lightning simultaneously with 3 cameras or more and reconstruct the lightning channel. And we also want to acquisite the greatest number that we can from one single thunderstorm and compare the lightning characteristics of singular thunderstorms. And the other is to continuously evaluate the Brazil DAT and HINDAT the need for a manual operator. So these were the 2 sensors installed in both sites during the Chuva campaign. And it's just let you see what we have. And these are the locations. In blue, there are the 2 locations where the sensors were operational during the campaign. And in orange, we have a 3rd sensor that operated sometimes during the summer. It was not operational all the time. And it was the same sensor, but sometimes was in the site 1 and site 2. Well, as I told you, the first sensor was operational in his first campaign during the Chuva campaign. And we installed the first one in November and the second one in December of 2011. And we had some problems with the sensor as it was the first campaign, and it prevented to be operational for the whole period of the campaign of the summer. So I made a rough estimation of the detection efficiency based on the total number of videos recorded against the ones with lightning flashes inside the field of view. So this is the first column where I just pick all the data and compared with the data with flashes inside the field of view. And it was a poor detection efficiency. But as these cameras are fixed, we have some other problems. For example, the thunderstorms in the Vale do Paraíba region happens in some singular ways. One of the ways is the cold front that come from the southwest to northeast, and like in this direction. And the other ones, the local convective thunderstorms, are formed in these regions, which are developed by the chains of mountains that surround the Paraíba Valley. And if, for example, we have one thunderstorm in here, these cameras will be facing this direction, and for example, this one was facing this direction. The lightning flash that occurred here, they will have the brightness of the lightning will spread through the other clouds that were in the region, and the photosensor, all photosensors will trigger the event. But unfortunately, we won't have the lightning flashes caught by the cameras. We have other situations, like for example, if the thunderstorm is surrounding one of the sites, one of the camera may be able to see some lightning, but the other one is completely clouded by the rain shaft. And this is the best of the observation, the best situation for observation. We have one camera looking for one side of the thunderstorm, the other camera looking to the other side, and we may also have other lightning recorded by both cameras or 3 cameras, for example. And we may have some thunderstorms coming from the left to the right, and some of the lightning flashes we will lose, and we will just see when the thunderstorm is in front of one of the cameras. So it may happen here too, and here. So I just did another way to calculate the detection efficiency in this table. I used only the videos that were the first video that had one lightning flash recorded, compared to all the all other videos inside. I mean, it's I just did this estimation for the period where the thunderstorm was in front of the field of view of the cameras. So this is an improved result. Some of them are still a low detection efficiency, but it's characteristics like flash multiplicity, duration, interstructure intervals, etc. And we can study also continuous currents that are better viewed with high-speed cameras than any other equipment. And in the case of Chuva, if we use this data with other equipments, we may enrich our analysis very much. We may do a deep analysis on physical parameters of lightning if we use lightning location systems to estimate the peak currents, or we can compare peak currents with other lightning characteristics. We can use as ground truth to the detection efficiency studies of the lightning location systems. We can use multiple cameras also to locate lightning flash and compare with locations from the lightning location systems. Study the dynamics responsible for some lightning observations, and we can do several other works with that. And just to illustrate what we are doing, these are the current work in progress that we have today. We are studying with only the data from RAMMER network the 2 cases of natural bipolar downward flashes, thunderstorms that produce positive lightning flashes in abundance, Analysis of the relationship between luminosity of return strokes and peak currents, which will be presented later today by Leandro. Daily analysis of flash characteristics for selected thunderstorm days. This work will be presented in SIPDA this year, so if you attend there, you will be able to see. And lightning channel reconstruction with multiple camera network. We already have some data recorded with 3 and 2 cameras. And detection efficiency calculations for BrazilDAT and RingDAT. These are the current work in progress. So just to illustrate something, these are the bipolar case studies. It's an integrated image because I was afraid that the video would take some time to show. And this one image may talk for 1,000 words. So it's the positive flash, a lot of recoils, and all the subsequent strokes went through the same channel. And the development of the negative subsequent strokes were all visible below cloud base, which is very rare to see. And in this case is another bipolar flash with the subsequent strokes being produced by recoil leaders, but going to a different ground contact point. The recoil leaders are present in the whole image, but when we integrate, they just fade away, so we can see the whole thing. And to let you see how it was the initiation of the negative return strokes. This is the recoil that gives the initiation, and it propagates, encounter the previously ionized channel by the positive flash, and went to the ground. And this is the sequence: the positive one, the first, subsequent, the second, third, and fourth. And as you can see, there is a horizontal development here of the positive leader. And this is the storm-by-storm analysis. There is a lot that we want to do, but this is just a sneak peek of we are using. We have two cases. In fact, we have 5, but here I'm only showing 2. 78 flashes recorded by 4 cameras, 120 flashes recorded by 4 cameras, 2 different days, and the statistics, some of the statistics are quite different. 21% of single stroke flashes, 16%, 5.15 of mean multiplicity, 4.5. These values are even different to values from Saba et al. 2006, for example, and other works that has been done with mean multiplicity, which is 3.9. And the ground contacts are the flash that produced different ground contacts were very similar, but in this graph we may see that when the lightning produced more than 1 ground contacts, for example, we have one case with a lot more ground contacts than in the other case, in the other day. And this is also the multiplicity, the distribution of multiplicities, which is also different from one case to another. And this is last slide with the one lightning flash observed by 2 cameras. So you can see the quality of the image, and we can work with that. Even though it's only 2 cameras, we have almost 90 degrees between one site and the other. So we can do some work with this flash. And for the participation of the Chuva campaign, we think that with the several instruments that we have at our disposal during this campaign, it's a unique database of lightning information. Cameras, LF, VHF, VLF, and other sensors, that radar, and etc. So for the discussions, they are mostly the ILDC talk, so as my time is up, I just leave here the expectations to see you using this data. They are available to everyone. So if you have any questions, you can look for us. And thank you.
Thanks, Antonio. So it's open for questions. Please, Ken.
Can I have a question for him?
Yes. Go ahead, Jeff.
Do you have a web page that you display all these flashes?
No, we don't have a web page with that information, but it's a good idea, and we plan to have one, but we still need to process the data and have everything done with the comparisons with the LLS prior doing this web page. But in the Chuva FTP, you have access to the temporal analysis of the luminosity. So you might see the case you are interested in and ask for the data, and you can send the whole videos.
Okay, so I just have a comment. I think it's a great data set. I think thus far it's early enough in the analysis that everybody is really busy scratching their heads about their own data sets right now.
Yeah.
And the deep looks into specific flashes and maybe overall, validation things should be a next step. And I think it's a great data set for that.
For the second bipolar lightning flash, was it also the first stroke being positive and only one positive stroke and all the others were negative?
Yes. Although we have one that was measured by one of the LLS networks has positive, but other LLS has negative. So we think that maybe we saw one of the networks saw an intra-cloud process of some kind, but it's basically the same.
Okay.
No, not this time.